Welcome back to Lesson 1 on the tangent property. Here we will be using the tangent property along with the Pythagorean theorem to help us find missing side lengths in triangles. So example 1, line segment GH is tangent to the circle with a radius of 6 centimeters. If OH is 10 centimeters, what's the length of GH? So now, knowing that GH is tangent, we can mark that angle as 90 degrees. And if the radius is 6 centimeters, that would be this distance here. Because radius is from the center of the circle to the outside edge. Now OH, this line segment here, is 10 centimeters. And we're looking for GH, we're looking for the length of the tangent. So now, if we have a right triangle and we're looking for a side length, we can use the Pythagorean theorem, which says that a squared plus b squared equals c squared. Now, if we're looking for a leg, like we are in this case, we start with the leg squared and set that equal to the hypotenuse squared minus the leg squared. So 10 squared minus 6 squared. Working that out, I get 100 minus 36, which is 64. Now to find x, we need to find the square root of 64, which is 8. So now that we can say line segment GH is equal to 8 centimeters. For example 2, we have to determine the radius of the circle to the nearest tenth if line segment JK is tangent to the circle. So if it's tangent, then this is 90 degrees. And we can't use the Pythagorean theorem unless we know we have a right triangle. So it's important to be told if a line segment is tangent. So now if we're looking for the radius, that's this side here. So again, I'll set up my Pythagorean theorem by saying x squared is equal to the hypotenuse squared minus the leg squared. Now, 24 squared is 576 and 18 squared is 324. Subtracting that gives me 252. Now that's x squared. If I want x, I just find the square root of that. Now my calculator, once I round, I get 15.9. So we can say that the radius is 15.9 centimeters. Now for example 3, it tells us that the diameter of a circle is 15 centimeters and the tangent line is 11 centimeters. What is the length of MP to the nearest tenth? Now the diameter is the distance across the circle. It goes through the center. Now if I want to know the radius, I'm just going to have to half the diameter. So I'm just going to make a little reminder that the radius is half the diameter. So if I take 15 centimeters and divide that by 2, I get 7.5 centimeters. So that means that the radius is 7.5. Now as a note, O to M is also 7.5. That's another radius here in this diagram. Now what we're looking for is M to P, this length here. And the tangent line is 11 centimeters. Since it is a tangent, we know that that's 90, and we can again use our Pythagorean theorem. Now if I'm only looking for M to P though, what I'm going to have to do is find this distance here, O to P, which I can call x, and then after I find what x is, I can then subtract 7.5 from it to find how long MP is. So now since I'm looking for a hypotenuse here, I'm going to say that x squared is equal to 1 leg squared plus the other leg squared. So I get 56.25 plus 121, which is 177.25. Now I need to find the square root of that. And rounding down my calculator, I get 13.3. So now, like I said, MP is going to be OP subtract 7.5. Now OP was X here, 13.3. If I subtract 7.5 from that, I get 5.8 centimeters.